Hello. We'd like to introduce our Security Information and Event Management Accelerator, which would be a demonstration of how our team applies Databricks native capabilities to simplify and accelerate security data processing. But before jumping into the demo, a quick word about who we are. We are a data and AI company with teams focused on data engineering, data science and AI, and cybersecurity and software. And for the past 3 years, we've been building and delivering high-impact data solutions for our clients. We're proud to be among the top 5 certificate holders in Canada, with over 140 certifications, 82 of which are from Databricks. Our team also holds a wide range of certifications across other leading technologies, from cloud and DevOps to cybersecurity and data platforms. Our expertise spans a wide range of domains. We've developed deep capabilities in finance, particularly in fin crimes and anti-money laundering, payments, and reconciliation. We've also led several platform migrations, including SaaS, and built accelerators from SAP for SAP and Lakebridge migrations into the Databricks. And beyond finance, our team has successfully delivered projects across industries like healthcare, government, and education. And finally, we have a strong security practice with extensive experience in cybersecurity and security information and event management, where we deliver solutions in highly regulated environments, including financial institutions. And it's this specific experience that forms the foundation for today's demo, where we'll walk you through our accelerator and show how our team applies Databricks best practices. Here's a quick overview of our security expertise. Our security team works extensively with Microsoft technologies. That includes Azure, Entra, and Sentinel. That's to monitor and protect enterprise environments. We leverage these tools to maintain detailed activity and audit logs across both Azure and Databricks, ensuring full visibility and compliance. Our team also builds secure automation frameworks using GitHub Actions for CI/CD and manages access control through Terraform integrations. And of course, we oversee all aspects of network security to maintain a strong defense in-depth posture across all the environments. Now, let's get into the accelerator itself. This accelerator is an end-to-end implementation of Microsoft Sentinel analytics rules built entirely within Databricks. We designed it by ingesting and transforming security data from multiple sources, following the best Databricks practices for engineering and security. The outcome is clean, centralized data model that supports advanced incidents management and alerting. And more importantly, the data is mapped into standard security schemas like OCSF, which makes it easier to integrate and extend across other tools and systems. Here's a high-level view of the accelerator architecture. We're ingesting data from multiple Microsoft sources, including Entra and Defender logs. Those go directly into Databricks, which is governed by the Unity catalog. The pipeline follows the medallion architecture pattern, where raw data first lands in the bronze layer, then it gets refined and enriched through silver layer, and finally aggregates in the gold layer for analytics and reporting. From the gold layer, we automatically trigger alerts to the security team whenever a Sentinel rule is matched, and we visualize the insights through interactive dashboards in Databricks. This approach ensures both real-time visibility and full governance of the entire data flow. Now, let's dive into the demo and see the accelerator in action. Let's start with the dashboard. This is a central view of our security operations powered by Databricks. You can see an overview of different security incidents detected across different environments. That includes MFA spamming, simultaneous logins, privileged role activities, and USB file copy. You could filter the incidents by the type, by severity, and then the incident ID. You could also filter it by the date range. You could see some of the visualizations and statistics over here, as long as represented in the form of a time series over here and here. You could also see a more detailed view of the table over here, where you get the details on each incident and the summary view on who that was initiated by over here. For the purposes of this demo, we'll be using USB file copy incident, which represents a case where a user connects an external device and attempts to transfer the data. But let's go beyond and see what happens behind the scenes. What you're seeing here is our production pipeline in Databricks, which is managed through Databricks asset bundles. You can see tasks here. Each task represents a stage in our workflow, starting with the bronze ingestion and then going all the way to the data contract test task. You could also see that the pipeline is parameterized. You could see all the tagging that we use for traceability. So Databricks asset bundles, in this case, allows us to define, version, and deploy all the pipeline assets, including notebooks, the dependencies, and the parameters. We could also go ahead and see how this pipeline would be deployed. This is a sample of GitHub Actions workflow that is being automated for this accelerator. So whenever a certain change is pushed, maybe a data contract has been changed or a pipeline has been modified, the workflow automatically runs end-to-end. So it checks out the repo, it goes through authentication steps over here, installing certain libraries that we need, creating the data contract, and finally deploying everything with Databricks asset bundles. And after that, it would appear as the most recent run on our pipeline over here. So let's have a look at how the pipeline run would look like from the inside out. You could see over here how each box in this pipeline represents a certain task or a stage in our workflow, starting with the ingestion into the bronze layer over here, how then is being transformed in our silver layer using Spark structured streaming for deduplication and the use of declarative pipelines over here for streaming purposes. And that running all the way down into our gold layer where our incident tables are created and our data contract tests are running. But let's have a look at how the data is being transformed end to end. To do that, we would like to start with looking at the bronze layer and how the Event Hub data is being landed in our system. So as you can see here, we are choosing our event logs for device events where the data is being ingested in its pure raw form over here, along with some metadata on when the table has been ingested. And after silver transformation, this is how the same data would look like in the silver layer. You can see that the data has been filtered out and it has been refined. You can see a better view of the table over here with some properties along with same metadata over here. Now, after the data goes through our bronze and silver layers, it would finally land inside our gold layer. For the gold layer, we'd like to show you a Unity catalog view instead. So what you are looking at over here is where our production-ready data resides. This is fully governed by the Unity catalog. You can see the access alert schema, which contains several tables over here. You could also notice that we also have tags set over here that we use for traceability and cost management later on. But let's go ahead and open the table that we're interested in, which is USB file copy alert. You could see that from the Unity catalog view, you could have a look at how the data looks like with its respective schema, data types, and then the comments. We will later on see the exact same comments in our data contract. We could also go and have a look at how the sample data would look like inside our gold layer. You could see this would be the most refined view and user-friendly view over here with all the details regarding the USB copy alerts. We could also go ahead and check the permissions where we've implemented fine-grained access controls, where only privileged user groups and developers could query this data, following the principle of the least privilege. We could also go ahead and look at the data lineage. Now, if we have a look at the lineage graph, this would be the table that we're interested in. This would be the table that we just looked at. This would be its downstream table. And then these would be the tables that are upstream. So you could see that this gold table is being constructed using some of our silver tables. We could also go beyond that and have a look at the bronze layer and how we can trace the data end to end. more than that, we could also open up the columns over here and then see where each column came from. So let's go back to our overview and have a look at our schema over again. Because next we would be looking at the data contracts. So data contracts are an essential part of our workflow. You can see a sample data contract for this specific accelerator. It has some info and details on the servers and the terms of use. You could also see the entity relationship diagram over here. This would be the table that we just had a look at, USB file copy alerts, along with other tables and their relationships. All of that is followed by a data model that would remind you a lot of the Unity catalog view that we just saw, but it has more detail to that. We could go ahead and find the table we're interested in, which is USB file copy alerts. You could see that the table is streaming. You could also see the fields that we've been using, the comments, types, as well as some examples. The OCSF schema that has been mentioned before is also part of the data contract. If we go all the way down here, we could see the OCSF actor login detail table. This is the schema, the downstream schema where our data is being mapped into. If we go back into our Unity catalog and we have a look at the sample data, and if we go back into our pipeline run, we could see a task dedicated for validation. So this is our data contract test task, where we validate that everything that is present inside this table satisfies the data contract quality check and the data contract itself using the test cases. So here you can see hundreds of test cases where we are ensuring before exporting anything that everything inside the table over here is satisfied based on this contract over here. This is how we validate the data along with the unit test cases that we also run along this pipeline run. Going back into the dashboard view, this would be the main tool that the security operations would use. Another thing that they would receive would be an email alert if an incident has been triggered. This email would include some details on the alert itself, the event time, the severity, and then some more details on the query and the user ID. So we could use the dashboard that we have over here to filter down the incident to a specific date. Let's say it was October 20th. October 21st. And let's say we filter down to our use case, which is USB file copy. We could find the alert from the email over here with the alert ID. All we need to do is copy this alert ID, open our alert details, which is a more detailed view on the alerts that have happened throughout the day. Refresh the page. And in our case, we would be specifically interested in the USB file copy alert. So let's go ahead and paste our incident, and you could see the incident filtered by the alert ID with more details on what that has happened so that our security team could act on it. All in all, this was an end-to-end flow from data ingestion in the bronze layer, our silver transformation, all the way into our gold layer and the dashboard view. So we'd like to go back and then summarize everything that we talked about. To wrap up, we've just seen the accelerator delivering end-to-end security automation on Databricks. It's built using production-grade engineering practices with Databricks asset bundles, CI/CD, and automated testing integrated with the data contracts. Our advanced data pipeline design leverages declarative pipelines and structured streaming. The entire solution is governed by the Unity catalog with data lineage, ACLs, and metadata tagging. And finally, everything that we've shown from medallion architecture to the OCSF aligned data contracts follows the best practices and is easily extensible for our new use cases and new clients. Thank you for watching this, and have a nice day.